Okay, here's the deal with the IRDa peripheral. This is the last on the CPLD that I have for the moment. What you're seeing on the right is a kind of a general idea about how the IRDa peripheral is built. So I've got the two emitters in line. This is the resistor I misspec'd and have subsequently replaced. I think this is on the high side though, actually on the board. I forget. And it has a big tank capacitor, which is actually a series of capacitors, but you get the idea. So there's a pulse width modulation signal that gets driven from the CPLD that, given the data coming in, which the CPLD also knows about, we can tell how many times those LEDs have come on, and since we know everything there is to know about this capacitor, we know how much charge is going to run through those LEDs on every single pulse that goes through it. So in this way, I hope to be able to control the emissivity strength of the LEDs. Now, this would have been easier to do by tying, say, the DAC pin of the CPU up through into the CPLD board. I wasn't feeling that brave on this occasion, so this gives me some flexibility that, okay, even if your analog modulation idea doesn't work out, you can always just toggle that pin on and run at full voltage all the time. But it would be nice to not have to, given that I put a powerful emitter in here. The IR emitter is a significant current draw, so it would be nice as if I was only using the IRDa peripheral to communicate glove to glove, which is the basic idea. It'll probably be one of the first use cases. Even if I was, there's no reason to scream, so why waste current doing so? So that's what that's for. But you could also potentially use it for range finding and whatnot. The actual data to be sent comes through and toggles this transistor. So that's the general idea. There's the IRDa spec itself has strict modulation parameters that you must adhere to if you are to be IRDa capable. So there were already IRDa PHYs on the market, as well as the transceiver modules, but that's a different story. The transceiver modules are just the photodiode and the emitter, but the PHY is actually the thing that takes your serial line data and converts it into the pulse widths required for IRDa spec. So there were many of these on the market, and I didn't go with any of them because they all seem to have a frequency top end of around 250 kilohertz. Unless I wanted to get into something I didn't understand very well. So the strategy is going to be to use a counter and the oscillator on the CPLD board, which I got to be very, very high accuracy, to actually drive an IRDa PHY in the CPLD, which shouldn't be too difficult considering a lot of the schematics that I saw that manufacturers had posted about how their own products worked. So I'm reasonably confident that I can get that done without much trouble, and with probably only 10 flip-flops. Actually, it would have to be probably 20 if I wanted it to be, if that rate to be settable via SPI, which is also on the table. I've got more than 2/3 of the CPLD left to play with, so there's a lot of room in there. This is going to have to be one of those things that evolves as demand becomes clear. But I did build it in a way that I believe general enough to make it work for a lot of things that I couldn't personally envision, which has been kind of the theme that I've used throughout this whole project. So that's basically all I have to say about the IRDa peripheral for the moment. There's going to have to be a whole lot more conversation about it as the time draws close to start talking glove to glove.